Hello everyone and welcome back to Diksha Karnataka YouTube channel. So we have already started our PU2 Brahmastra series, and today day 2 of PU2 Brahmastra series we are going to discuss physics chapter 1, very important chapter, electric charges and fields. Okay, so if you are wondering, if you are struggling with this chapter, what all you have to study, what are all the important questions, how to write the answer, how we will get the marks if I write some part, if I write this part. So everything I will discuss in this lecture. This will be one short lecture for this entire chapter. Every questions, every important questions, every important numericals, MCQs, everything will be done in this lecture. And if you want the class note for this lecture, you have to do two things. You have to join our WhatsApp channel, and there is a form down there. You have to fill that form to get the latest class notes that we are doing here in our lecture series. So you don't need to worry too much before your exam, okay, which book to study, which material to follow. So everything will be done here with explanation, proper explanation. Okay, so don't miss out on that. Join our WhatsApp channel and also fill the form so that you get the lecture in your mobile. Okay, now let's start with the blueprint. Okay, we know that currently PU board has 3 different blueprints, and according to different blueprints the marks distribution varies slightly and question distribution also varies slightly. So let's look into the first blueprint. Okay, in the first blueprint we can see that there will be one remembering based MCQ questions, one short answer type understanding questions. So what is the meaning of remembering, understanding, application, etc. So just give you a hint that remembering means it's easy. You study it, you remember the formula, you remember the equation, you remember it, and you can write the answer. Okay, understanding means you have to understand it. Okay, and 2 marks and 3 mark questions are based on understanding, sometimes application. Okay, there is no understanding question in the MCQ. In the MCQ there are mainly 2 categories, which is remembering, that is straightforward directly asked question. For example, what is the unit of charge, what is the coulomb is the unit of what quantity. So directly they will give you some information and you have to answer that, okay, without using too much of your head. Okay, then there is a type called HOTS question. HOTS question means higher order thinking skills. So basically they are testing whether you can figure out the answer when the question is not asked straightforward, but it's little bit complicated way. Okay, so they will probably they will ask you what will happen if this is done by this way, like that. Okay, we will look into that in our next chapters. This chapter, in all the blueprints, blueprint 1, blueprint 2, blueprint 3, you can see that the MCQ question is remembering question. Remembering question means you have to remember all the concepts, all the units, all the dimensions, all the formulas. Okay, so if you remember everything, you can answer the MCQ from this chapter. Okay, in blueprint 1 we are discussing. In blueprint 1, short answer type question is understanding based question. Understanding based question means maybe small explanatory questions. Okay, for example, Coulomb's law in vector form. Okay, you have to understand that, then only you can write that answer. Okay, then short answer type 3 mark question, which is also a remember based question. You can directly remember it and you can write Coulomb's law, state Coulomb's law and explain. Okay, or write 3 properties of charges. That is a remembering based question. Okay, next is long answer type application questions. Even though this says application question, actually you can remember it and you can write it, because all the derivations, all the calculations are already done in your book. So even though it's an application, it's basically a remembering question. Okay, so you can remember this question. Now let's look into blueprint number 2. In blueprint number 2, only difference between blueprint 1 and blueprint 2 is that there is no long answer type 5 mark question, but there is a HOTS question, which is a numerical question. Okay, so numerical questions can be slightly difficult for this chapter. Okay, and only one blueprint is giving it, but you don't know which blueprint is going to come in your final exam. Last year there was some confusion happened because some questions were not exactly according to the blueprint, so students were saying that it is not according to the blueprint. So to remove that ambiguity, they have given you 3 blueprints. Okay, any one of the blueprints or mix of them can come in your annual exam. Okay, but as you can see, both blueprint is giving 11 marks from this chapter. So out of 100 marks, if you out of 70 marks, if you study this chapter alone, you can answer up to 11 marks. Okay, and in blueprint 3 they are giving it 10 marks. So this is also very important chapter, and in this case they have added one fill in the blanks question. So one remembering based MCQ, one remembering based fill in the blanks, no short answer type question, one 3 marks question understanding based, and one application based long answer type question. So from calculating both all 3 blueprints, it is clear that derivations is very important from this chapter, because 2 out of 3 blueprint is giving you derivation from this chapter, right? And numerical is slightly medium important, not super important, but those who are preparing for KCET exam, okay, those who are slightly better in terms of rest of the class, they should definitely solve numerical questions. Numerical is optional for those who are just starting today with me. Okay, they have not done anything in their entire second PU till today, and if they are starting today with me, you can skip the numerical portion for this chapter. So this is a very important helpful tip for you. So I will take care of both section of the students, the higher order students, those who are little bit better in terms of study and they are serious about their exam, and those who are casual, they think, okay, if I just pass physics, I score 21, I score 30 marks, I score 40 marks, that is sufficient for me. I will take care of them as well. I will try to make increase their current level by at least 10 marks. So if you are scoring 30 marks right now, I will try to help you to achieve at least 40 marks in your annual exam, and if you are scoring 40 marks, I will try to help you 50 to 55 marks in your annual exam. Those who are scoring 50 plus, I will try to help them to get as close as to 70. Okay, out of 70, right? So 50 plus is very good, very strong. They may lack some knowledge in numericals, they may lack some knowledge in derivation, so I will take you along with me to reach the 70 marks guideline, right? Also, what are all we are going to discuss today? We are going to discuss 15 MCQ from this chapter. Very important MCQs. I have seen students are making very silly mistake in MCQs because either they are not practicing them, or they are not getting a chance to practice, or they are thinking from where to practice the MCQs. Don't worry, I am here with all the MCQs possible from this chapter, important MCQs possible from this chapter. Now remember that while practicing the MCQ, I have given a question. Suppose what is the unit of charge? Okay, the options are given: coulomb, Newton per coulomb, okay, volt per meter, volt, etc. But in the exam, so last year or last to last year, there was a question which asked that coulomb is a unit of now they have give you charge, electric field, electric potential, electric capacitance, like that. So the question may be asked in a reverse format as well. So if I give you a question, if the question is asked in the reverse format, then also you are supposed to answer that question, right? I hope that is clarifies. In case you are getting any question from these concepts, I hope everyone will be able to answer that question. Now also the fill in the blanks is not super important for this chapter, but still we are doing 5 fill in the blanks from this chapter. Then we are doing 5 2-marker question from this chapter, okay, and 4 3-marker question from this chapter. All concepts will be covered through this, and then 4 long answer type derivations and 5 numerical questions. So total 38 questions we are doing all together in this lecture. So 38 question we will be discussing in this lecture today. So let's start without any delay with the MCQs. When a body is charged by electric induction, the total charge on the body is. So this is from one of the previous one of the midterm question paper that I collected from one of my student. So the question is, when a body is charged by electric induction. So electric induction, if you remember, electric induction does not produce new charges, it only separates the charges to plus and minus, right? So total charge on the body is neutral, right? Because in electric induction no external charges are added, okay, only whatever charge inside the object, that is been polarized. We call the term polarized. So positive goes to another side, negative goes to another side, but if you remove the source, they again recombine and give you a neutral object. So the total charge will be neutral, right? Next question: electric field due to an electric dipole at a distance r on the axis of the dipole is. So this is also one of the questions I collected from one of the midterm question paper. So electric field due to an electric dipole at a distance r on the axis of the dipole is, we know that it is inversely proportional to r cube. We will do the derivation today, and I hope that will help you to remember it. It is not 1 by r square, it is 1 by r cube. So 1 by r cube means inversely proportional, right? Electric field due to a dipole on the axis or on the equatorial plane, in both cases it is 1 by r cube, right? So it is 1 by r cube. 1 by r cube means inversely proportional to r cube. Okay. Next question, the SI unit of electric flask is. So what is the SI unit of electric flask? So let's understand what is electric flask is. I will just do this mathematics today so that you are clear about any doubts that you might have. Okay. So what is electric flask? Electric flask is charge enclosed divided by epsilon naught, right? That is Gauss's law. So this is the basic definition of electric flask, right? Now what is the unit of charge? Unit of charge is coulomb. What is the unit of epsilon naught? What is the unit of epsilon naught? So in this case, either you can remember the answer, correct answer, or you can derive it. I am giving you a way to find it. Now where we are getting this value epsilon naught from? We are getting this from Coulomb's law. So Coulomb's law states that force between two charges is 4 pi epsilon naught, 1 by 4 pi epsilon naught times q1 q2 by r square, right? You remember that? So this is the formula. Now what is this? This is force. So force means what? Force means Newton. Okay, this is a unitless quantity, we don't need to worry about it. Epsilon naught is epsilon naught. We are trying to find the unit of epsilon naught. What is the we are trying to find, in fact we are trying to find 1 by epsilon naught here, right? So if we find 1 by epsilon naught, you can write this as, you can write this as 1 by epsilon naught times q. So q's unit we already know. If we can find the unit of epsilon naught, 1 by epsilon naught, that will be enough for us. Now what is the unit of q1? q1 is coulomb, q2 is also coulomb, so q coulomb square. What is r? R is distance, distance square is meter square, so coulomb square by meter square, right? So what is 1 by epsilon? So 1 by epsilon naught is Newton. So cross multiply, it will go up, meter square, coulomb to the power minus 2. This is the unit of 1 by epsilon naught. Now here let me add the units now. So Newton, meter square, coulomb to the power minus 2, and there is a charge also, so this is another coulomb. Okay, simple mathematics. Using simple mathematics, even if you don't remember the answer, you can answer by finding it. Okay, you have enough time. This is not your KSET exam or NEET exam or JEE mains exam where you don't have time. Here you have plenty of time. You can do this mathematics in case you forgot some answer, some derivation, some values. Okay, so from here we can say that correct answer is option C, Newton Coulomb inverse meter square. Right, now you have to check what all values are matching. The order may be different. Okay, order may be different in this case because you have written in your own order, but if you check, so Newton is there, Newton is there, meter square is there, meter square is there, Coulomb inverse is there, Coulomb inverse is here also. Okay, so this is how you answer difficult questions. So difficult question, if the question is appearing to be difficult, which is uncommon, okay, you can use this mathematics and calculate it. Now if they ask you the other way around, what is which quantity is represented by this unit, then you have to remember it. You have no other option. Okay, whether it is electric flask or then there will be different quantities. You have to calculate the units for all the quantities, which is very difficult, right? But in this case you can calculate this way. There are different formulas. You can use any one of them to calculate this. I have used the basic fundamental Coulomb's law. You can use E times E dot ds equals to q by epsilon naught. That is also fine. Whatever way you are comfortable with, you can use that formula to calculate. Okay, now charges are conserved for open system, isolated system, any system, No system. This is a very interesting question. I know most of you will answer option C, any system. But charges are not conserved for any system. It is only conserved for isolated system. When the system is isolated, no exchange of matter or no exchange of charges are happening from outside. If the charges are being exchanged from the outside, then how can you say that this charge is conserved? But if the system is isolated, no exchange of matter is happening with outside, then definitely charges are conserved. So correct answer is isolated system. Okay, this is a trick question and it's a memory based question, so if you know the answer you can answer it. Next, the value of the basic unit of charge. So very common question. The value of basic unit of charge is 1.6 times 10 to the power of minus 19 coulomb. We know that. Don't fall for any other traps. Okay, it looks at similar. 1.9 times 10 to the power minus 16, 6.25 times 10 to the power 18. This is actually number of electrons in 1 coulomb charge. Okay, number of electron in 1 coulomb charge. So you can remember this value. This will be helpful for you. Okay, otherwise this is also not incorrect. Only correct is this. Now next question. Two electric field lines can never intersect, always intersects, may intersect, always perpendicular. Can never intersect. Obviously this is a very common question from the properties of electric field lines. So if you know it, you can answer this. Next question. Gauss's law is true for any surface, only open surface, only closed surface, only spherical surface. And now I know many students will also answer any surface. This is also incorrect. Okay, it is only valid for any closed surface. Okay, any closed surface, Gauss's law is valid. For any other surface, for any arbitrary surface, this is not true. Okay, if the surface is open surface, definitely not true. Okay, so only closed surface, Gauss's law can be applicable. Now, SI unit of electric charge is, so what is the unit of electric charge? Very simple, very easy, coulomb. No other option can be considered, even you cannot consider. SI unit of electric charge is coulomb. The total electric flux through a closed surface in air is equal to 1 by epsilon naught times the total charge enclosed by that surface. This is the statement of what? This is the statement of Gauss's law of electrostatics. So option C is correct. Gauss's law of magnetism is not correct. Now next question. The SI unit of surface charge density. Surface charge density. What is surface charge density? Surface charge density is given by charge divided by surface area. That is coulomb divided by meter square. So it will be coulomb meter to the power minus 2. So coulomb to the power meter to the power minus 2 is the surface charge density. Now here one catch. So there I have given you surface charge density. So they might ask what is line charge density. Line charge density, that you have to remember. Line charge density. If you remember the definitions, you can answer. Line charge density is length divided by, charge divided by length, right? So charge unit of charge is coulomb and unit of length is meter. Okay, so it will be coulomb per meter. Similarly, volume charge density is charge divided by volume, so it will be coulomb per meter cube. Okay, volume charge density, this is volume charge density, that will be coulomb meter to the power minus 3. Okay, so you have to remember these values. Okay, coulomb per meter cube, when coulomb per meter square is coming, when coulomb per meter is coming, when coulomb per meter cube is coming. So one question, this same question can be asked in 3 different ways based on what quantity they have given. Okay, surface, line or volume. Okay, now don't say that in your class you have taught surface charge density, in our exam volume charge density was asked. I explained everything. Okay, now a beaker contains a solution of substrate A. Sorry, this is a wrong question, my mistake. Question number 12. SI unit of electric field is, so what is the SI unit of electric field? Electric field is generally Newton per coulomb. Okay, so Newton per coulomb is electric field. There is another unit of electric field, you should know, volt per meter. Okay, volt per meter is also unit of electric field. Both are SI units, but from this given option Newton per coulomb is correct answer. But you have to remember volt per meter can also be unit of electric field. Okay, what is the nature of Gaussian surface involved in Gauss's law of electrostatics? Okay, so what is the nature of Gaussian surface? It's magnetic, it's scalar, it's vector, it is electrical. Now many of you will answer electrical. No, Gaussian surface is nothing to do with electricity or magnetism. It is a vector surface. Okay, because we do the dot product E dot ds, so ds is a vector, so that is part of Gaussian surface. So Gaussian surface is basically a vector quantity. Okay, it has at any point, if you draw the perpendicular normal to the surface, you get the direction of that point, right? So Gaussian surface is a vector quantity. Now the angle between the dipole moment and electric field at any point on the equatorial plane is, so the angle between dipole moment and electric field, okay, at any point on the equatorial plane. So what is equatorial plane means? So this is a dipole. Suppose this is plus q, this is minus q. Okay, then this will be in this direction, this will be in this direction, and the resultant will be in this direction, right? So this is the electric field due to a dipole on the equatorial plane. This is equatorial plane, right? This is the equatorial plane. Now what is the dipole moment? Dipole moment always points from negative to positive. Dipole moment always points from negative to positive. Okay, so two vectors each other, they are in the opposite direction. So E is in this direction, P is in this direction. So what is the angle? 180 degree. Okay, so the angle between dipole moment and electric field lines, when you are considering on the equatorial plane, they are 180 degrees. Okay, now if they ask you about axial plane, okay, on the axis of the dipole, then you tell me the answer. Mention the answer below. If the same question is asked, instead of equatorial plane, if they say what is the direction of electric field and dipole moment on the axis of a dipole, okay, I will not tell you the answer. You can answer that in the comment below, and if you are answering the comment below, I will say if it is correct or incorrect. Okay, now question number 15. The electric dipole placed in uniform electric field is unstable if the angle between the electric field and the dipole moment is. So this is a question from the last year. Okay, last year 2024, that is current year. Obviously you are going to appear next year. So current year annual exam question. So the electric dipole placed in an uniform electric field, and the angle between the dipole moment and electric field will be unstable in that case when the angle is 180 degrees. So dipole moment, this is an external electric field, this is not the internal electric field. Previous question is based on the internal electric field because of the dipole. Here dipole has its field, okay, but you have placed it in an external electric field. In the external electric field, when the angle of the dipole, suppose this is the external electric field, this is the dipole, okay, then when the angle is 180 degree, it will be most unstable. It will be most unstable. So correct answer is 180 degrees. Okay, now let's look into the fill in the blanks. One of the basic properties of electric charge is dash. So let's look into the options. What are the options? Never, dipole, quantization, vacuum, zero, always. Anything that is related to charge, anything which is related to charge, yes, we see that quantization is related to charge. So the answer will be quantization, right? So correct answer for this question will be quantization. Now a pair of equal and opposite charges plus q and minus q, okay, maybe only q and minus q, separated by a distance 2a is an, so what is this quantity? Two charges plus q and minus q separated by a distance 2a is obviously a dipole. So the correct answer is dipole. Check the options. If the dipole is given, obviously dipole should be given, so dipole is the answer. Next is the electrostatic force between two charges is maximum. So electrostatic force between two charges is maximum in, okay, so in that case the answer will be from the remaining option, never, maximum in never, is it making any sense language wise, linguistic sense? Is it making any sense? The electrostatic force between two charges is maximum in never. Is it making any sense? No, right? Maximum in vacuum makes some sense, right? Maximum in zero does not make any sense. Maximum in always does not make any sense. So if you read it correctly, after putting the option, read it in your mind and see if it is making any sense or not. So from there also you can sometimes answer some questions. Okay, sometimes it is tricky, sometimes it is not easy to answer, but at times if you are unsure, you can check that way. Okay, so electrostatic force between two charges is maximum in vacuum. Okay, now we know that if you add any dielectric medium, the force decreases, right? If you add any dielectric medium between two charges, the electric force decreases, and we will study that in detail in our next chapter. But since this is from electrostatic force, Coulomb's force, from Coulomb's law also we know that 1 by 4 pi epsilon naught. So if you replace that epsilon naught using a dielectric medium, then the force will obviously decrease, right? So correct answer is vacuum. Electric field inside a charged spherical conductor is. So what is the electric field inside a charged spherical conductor? Okay, inside a charged spherical conductor, electric field is 0. We already know that, so the answer will be 0. Okay, now two electric field lines will never cross. So now in this case, if you see, this is a distracting question. Here both the options, two electric field lines will never cross, two electric field lines will always cross. So both are making sense. So this distraction is actually given for this question. Okay, but in such cases you have to trust your knowledge, your memory. Okay, so in this case we know that electric field lines never cross, so that will be the answer. So sometimes your the way I taught you that you have to put the option and check if it is making any sense or not. Sometimes it is work, sometimes it will not work. When it will work, you can answer it by checking the options. If it is not working, that means they have given you option in a way that to make you confused. So in that case you have to trust your knowledge. No other option is left. Okay, I hope this helps you. This is just a guide. Any line they can take from your book and make you fill in the blanks. Fill in the blanks is the probability of making difficult for fill in the blanks is very low. Fill in the blanks are mostly easy. Okay, there I have not seen the very difficult fill in the blanks, but these are just for your reference. Okay, it does not mean that only this fill in the blanks will come in your exam. Okay, these are taken from some sample papers, some model papers. Okay, now let's move on to the next part. State and explain Gauss's law of electrostatics. This is a 2-star question. Okay, there is a 3-star question also, but this is a 2-star question. Why 2-star? This question sometimes come as it is, okay, for 2-mark short answer type question. Sometimes in 5-mark question, the first part of the question is state Gauss's law. In that case, they will not ask you to explain it, but they will ask you state Gauss's law. So if you study it, you are not only getting prepared for a 2-mark question, you are also getting prepared for a 5-mark question. Okay, so let's look into this answer. Gauss's law states that the total electric flux passing through a closed surface is equal to 1 by epsilon naught times the net charge enclosed by the closed surface. Very important. So what you have to be careful about, you have to mention this closed surface. Okay, you have to mention obviously 1 by epsilon naught. Okay, then you have to mention the charge enclosed by. Okay, so these are very, very important lines to remember, right? So these are very, very important line to remember. Somehow the highlighter is not working, I don't know why. Okay, so this is very, very important. This line, the closed surface. Okay, these are very, very important to remember. Here also charge enclosed. You cannot miss these lines, okay, these words. So they will check if you have marked them correctly or not, okay. So this is the Gauss's law. Now let's look into the explanation. So how to write the explanation? The explanation is that you can write that flask is given by Q enclosed divided by epsilon naught. So here you can draw a diagram that this is Q enclosed. So Q enclosed by flask coming out of the surface is fly. Just simple. Keep it as simple as possible. You don't need to draw too much. You don't need to write too much. If you just explain it using a diagram, fine. Okay, that's the flask coming out through a surface enclosed by the charge enclosed by it is Qn, then the flask will be Qn by epsilon. You can write that way, or you can just simply draw this diagram, write it. Full marks. Okay, now next question, write Coulomb's law in vector form. Okay, explain the term, state and explain Coulomb's law. Now this is the state and explain Coulomb's law is that this is a 3-star question, even 5-star question you can say. Okay, this question will definitely come. Okay, last 5 years, each and every year this question came. Okay, either it came as a 2-marker question, state and explain Coulomb's law, or it came as a 3-marker question, write Coulomb's law in vector form and explain the terms. Okay, both question can come, either it will come as a 2-marker question or it will come as a 3-marker question. Both question are combined in a single question. I have not given you an extra question. Okay, I could have give this question as a 2-marker question, and in a 3-marker question I will give the same question. No. Okay, you can remember only one answer for that. That is sufficient. Okay, if you remember only one answer, that is the vector form, that will be sufficient for state and explain Coulomb's law. Okay, so let's see the statement. Statement is Coulomb's law states that the electrostatic force between 2-point charge is directly proportional to the product of magnitude of the two charges and inversely proportional to the square of the distance between them. Coulomb's law in vector form is F vector equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay, in this case what you will do, you will write F12. Okay, F12. Here what you will do, this diagram is very important for vector form. Vector form answer is incomplete without a diagram. Okay, so here you have to do this force on charge 1 due to yes. So this is F12. Okay, this is R cap. So you have to draw this. This is F21. You can optionally you can draw this diagram. Okay, there is a diagram given in your book, but in that case you have to write the correct expression given in your book. That is slightly difficult to remember. This is the easiest formula to remember. That's why I gave you this formula. Okay, but you can write the formula given in your book, and I have seen some guidebooks, they are very wrong. Okay, many of the guidebooks, they don't know how to write Coulomb's law in vector form. So that's why I asked you draw this simple diagram, write this simple statement, okay, and then explain Q1 Q2 point charges, epsilon naught is the permittivity of the free space, R is the distance between the Q1 and Q2, so this is R. Okay, and R cap is the unit vector. If you write everything, you will get full marks. If you write this along with the diagram, okay, you don't need to explain too much, that will be sufficient for you to get full marks. Now next question, question 23. This is from one of your model question paper. Sketch the electric field lines of force due to a point charge Q. If Q is negative, less than 0 means negative, basically this means negative charge, and greater than 0 means it is a positive charge. So what will be electric field lines, okay, for a negative charge? So Q, So here Q is negative, less than 0. So negative charge means if you have a positive charge somewhere, okay, positive unit positive test charge, that is the criteria. So unit positive test charge will be attracted towards you, right? So unit positive test charge, your best friend, it will be attracted towards the charge. So this will be the field lines, lines of force, field lines, whatever you say. This will be the simple diagram. Okay, you can continue drawing as many lines as you can. Everything will be like this. So this is a field line for when it is negative, that is less than 0. Now what will be the field line when charge is greater than 0? So in this case Q is greater than 0. So this is a positive charge. So positive charge means what will happen, all the field lines, if you keep any positive charge, unit positive test charge, in which direction it will move? It will move away, right? So it will move away. So it will be in this direction. Use scale to draw the lines properly. Don't draw like me in hand. Okay, spend some extra time. So this is sufficient for you to get 2 marks. Okay, this is for less than 0, this is for greater than 0. That is positive, this is negative. That's it. You have to understand what is the meaning of less than 0, greater than 0. If you understand that, your answer, you can answer. This is a very easy question. Okay, only trick is to understand what is the meaning of less than 0, greater than 0. Okay, define electric dipole moment, mention its SI unit. So what is electric dipole moment? So an electric dipole moment is a pair of dipole. When you want to define electric dipole moment, first you have to define electric dipole. Very, very important. Okay, so first you have to define electric dipole, then only you can define electric dipole moment. An electric dipole is a pair of equal and opposite charges Q and minus Q separated by some distance 2a. Okay, so that is the definition of electric dipole. Its dipole moment, vector P, has magnitude 2qa and is in the direction of the dipole axis from negative to positive. Okay, so you have to be careful when you are defining dipole moment. So if you say that the electric dipole moment is defined by 2qa, now what is q, what is 2a? You have to explain that. So a dipole is basically defined by two equal and opposite charges plus q and minus q separated by a distance 2a. Now the quantity 2qa is known as dipole moment. It is a vector quantity. Its direction is from negative to positive. You don't need to remember exactly these wordings. If you understand by heart, you can write it down even without knowing this. Now what is the unit? Unit, you can find it from here. Charge is coulomb, A is meter, so its SI unit is coulomb meter. Even if you don't know the answer, you can write it from the expression. 2qa, q is coulomb, m is meter, so coulomb meter is the unit of dipole moment. Right? Now, next question. The charges are additive in nature. Explain. So this is also from one of your model question paper, or I think sample paper. If a system contains 2 point charges Q1 and Q2, the total charge of the system is obtained simply by adding algebraically. Okay, that is Q1 plus Q2, that is charges add up like real numbers, or they are scalars like the mass of a body. That's it. This is sufficient, and if you want to write little more, I know none of you will write, you can give an example of real charges. For example, there are total system of charges containing 5 charges, plus 1, plus 2, minus 3, plus 4 and minus 5 in some arbitrary unit. Then the total charge is plus 1 plus 2 plus minus 3 plus 4 plus minus 5 equal to minus 1 in the same arbitrary unit. Okay, this part is optional. Okay, I explained this during your midterm exam as well, if you have followed our midterm series. Okay, so this part is compulsory. This part is compulsory. This part I have given you in case they ask you the same question in a 3-mark question. If you answer this in a 3-mark question up to this mark, this part you will not get 3 marks. You will get only 2 marks. You have to explain it using this example to get 3 marks. That's why I have added this as a bonus. Now, let's look into the 3-mark questions now. Derive the expression for the torque on an electric dipole placed in an uniform electric field. So we have uniform electric field. Now some of you may be asking, sir, you have done the same some of the same questions in our midterm section. Yes, midterm section also I have done similar questions, because all the chapters have limited number of questions, right? And if you are practicing them again and again, then only you will be perfect and you will be ready to write the same thing in your annual exam, right? For example, this is a very common and important questions from this chapter. Okay, last year I think also it came as a 3-marker question, or it might come in your pre-board. Okay, during a pre-board preparatory test, this question might come, so you have to be prepared. So now we have charges, a dipole kept in an uniform electric field. Okay, so uniform electric field, suppose the electric field is in this direction. This is say minus q, this is say plus q. The angle is theta. Okay, now what is the force acting on this charge? Electric field is E. You can describe this diagram, or the diagram you have to draw. Okay, to draw, if you draw the diagram, you will get 1 mark. Okay, the diagram is compulsory for this derivation. Without drawing the diagram, if you just remember everything, you will not score marks. You will get 0. Okay, if the teacher wants, they can give you 0. Okay, because it is mentioned, if you read the front few lines of your question paper, it says that whenever diagram is required, it is compulsory. If you don't draw the diagram, you will get 0 marks. The answer will not be given considered. So be careful. So in this case, the diagram is compulsory. Okay, so this is an electric field, external electric field. This is a dipole placed in it at some angle theta. Now what is the force acting on this negative charge? So negative charge, force experienced by the negative charge is given by charge times E, and it is in the direction of electric field. Negative charges experiences force in the direction of electric field. Sorry, my mistake. Negative charges will experience force in the opposite direction of the electric field. Positive charges will experience a force in the direction of electric field. Positive charges will experience a force in the direction of electric field. Negative charges will experience a force opposite direction of the electric field. Okay, now basically let me redraw this diagram once. Okay, because in your books I think the diagram is somewhat like this. This is plus q, this is minus q. Okay, so this will be in this direction, this will be in this direction. Okay, I hope this is fine now. Okay, now what we will do, we have to find the perpendicular distance between these two forces. What is the perpendicular distance between these two forces? For that you have to draw this dotted line and then draw a perpendicular here. So this is the distance. So say this distance is x. Now what is the distance between the charges? Distance between the charges we already know. Distance between the charges in a dipole is 2a. Okay, so this is 2a. This angle is theta, so similarly this angle will also be theta. What is this distance? So consider this is a triangle. Okay, perpendicular right angle triangle. This angle is theta, this is 2a. What will be this? So if you see, this is hypotenuse, right, and this is perpendicular for this angle. For this angle, this is opposite angle, so this is perpendicular. So perpendicular, we know that perpendicular by hypotenuse is basically cos theta, sin theta. Now how to remember that? There is a poem to remember. You can remember it via poem. Some people have curly brown hair turned permanently black. Some people have means, some means sin, people have means P by H. Okay, curly brown hair means cos theta, B by H, turned permanently black. Turned permanently black means tan theta equals to perpendicular by base. Okay, so you can remember like this. So this is the sin theta. So you see that perpendicular distance is nothing but 2a sine theta. So we have calculated the perpendicular distance. Now what is the torque? What is the definition of torque? If you remember in your first PU, torque is basically when two equal and opposite forces acting on an object separated by a distance, say L. If this is force F, this is also force F, but in the opposite direction, so minus F, then the torque is basically given by L cross F in vector form. Okay, so this is the torque, right? So from here we can see that the torque is nothing but the perpendicular distance. So let me write the scalar form first, then we will see what is the vector form. Okay, so torque is the perpendicular distance times any one of the forces. You can take magnitude of any one of the forces. Magnitude is sufficient. So the distance times magnitude, that is the torque. Torque is distance between the forces times the magnitude, right? So it will be P is what? P we have already calculated, 2a cos theta. You have to show this calculation, by the way, in the side right side of your calculation. That will be fine. Okay, you don't need to show this. You don't need to show this diagram though, but you have to show that here P equals to, suppose, or here we have mentioned x. So let me correct that. X equals to 2a sine theta. Okay, so x equals to 2a sine theta. Okay, now so here it will be x to a sine theta. I make now one more mistake here, 2a sine theta. Now what is force? Force is QE. We are using scalar form only right now. Now let me rearrange this. 2aq e sine theta. What is 2aq? 2aq is the dipole moment P. So it is PE sine theta. So you can leave your derivation here, or you can write one more line that in vectorially tau is equal to P cross E. Okay, vectorially tau is equal to P cross E. So this is the expression for torque. Now next question 27, write any three properties of electric charge. So this is a very common question, okay, and often asked. Okay, every alternate year I have seen these questions coming. Maybe in your year this question is very important. So additivity of charges. What is additivity? Charges are additive in nature. Quantization of charges. All charges are integral multiple of smallest charge E. Okay. Conservation of charges. Total charge is in an isolated system is conserved. So I expect you to write one line about the properties, so that you get full marks in case of doubt. Okay, also it makes an impression on the examiner. He thinks, okay, he or she will think you are a good student, you are studying very hard. So in case in future other questions maybe you have written something less, he or she will consider and give you the extra benefit. Okay, so this is a way to impress the examiner, because you are not seeing the examiner. Whoever is checking your answer sheets, they don't know you, right? To communicate to them that, okay, sir or madam, I am a very good student, I am working hard, you have to write these extra lines. These are a way to impress the examiner. I know many of you will write only the points. They will not bother about writing the extra lines, but if you are doing that, then you are basically trying to impress the examiner. In your college, fine, everyone knows you, whether you are a good student or you are just copying from your friend's notebook, right? Just jokes apart, but when you are writing for an unknown examiner, then they are neutral to you, but this way you can make them impress. Now question number 28, what is an electric dipole? Define electric dipole moment, give its direction. Okay, so I have almost answered this question once more. Let's see. Dipole is two equal and opposite charges separated by a small distance is known as electric dipole. Dipole moment is the product of the magnitude of one of the charges and distance between them is a vector quantity. The direction of dipole moment is from negative to positive charge. Okay, here you have to draw the diagram of the dipole. Okay, slightly different question, slightly different version of the answer, so you can, whatever way you want, you can remember that. Okay, whatever answer you want to remember, if you remember this question, you can answer all the questions from electric dipole, right? All the 2-3 marks question. Now let's look into the one more 3 mark question is there. Write 3 properties of electric field lines. This is also very common question asked from this chapter, and there was once upon a time this question was asked as a 5 marker question as well. So if your question paper level is easy, then this question might come as a 5 marker question, and you will be very lucky. You don't have to do any derivations, no difficult mathematics, but that is very unlikely. Only once in our entire previous year question paper analysis I have seen that, and probably that was when it was as a repeater question. Okay, so if you fail in your first exam, or if you want to take an improvement test, during that test I think this question came once. Okay, but this question as a 3 marker question is very common. 5 marker question is not common, but as a 3 marker question, this is very common question. Okay, so electric field lines may start from positive charge and end at negative charge. Okay, in a charge free region, electric field lines can be taken to be continuous curves without any breaks. 2 electric field lines are never intersecting each other. Electrostatic field lines do not form any closed loop. Okay, electric field free space decreases as we move in the direction of the electric field lines and vice versa. Okay, these are the 5 points. You can remember any 3 of them, and I request you to study 5 of them. Okay, maybe you will get lucky and this question will come as a 5 mark question. Okay, so prepare for the worst, hope for the best. So I am trying to make you prepare for the worst, but also I am asking you to hope for the best. So if this question comes as a 5 marker question, that will be the best situation. Okay, only writing these 5 points quickly, you will score 5 marks without doing any difficult mathematics. Now let's move into the 5 marker question section. Derive the expression for the electric field at a point on the axis of an electric dipole. So what is the question? We are trying to find the electric field on the axis of an electric dipole. So this is an electric dipole, and we are trying to find the electric field here on the axis. How to do that? So let's look into what are all the electric field on this point. So there are 2 electric field on this point. One, this positive charge. So how to find the electric field? First of all, to find the electric field, we have to put a unit positive charge at that point. Okay, we have to put a unit positive charge at that point, and whatever is the force between this charge and this charge, that is the electric field, right? We know that. And similarly, whatever is the force between this charge and this charge, that will be the electric field due to this charge. Now let's first find the distances. This distance is r. Okay, this is 2a, so this will be 2a, this will also be a. Right, now what is the distance between this charge and this point? The distance between this charge and this point is r minus a. Right, this entire thing is r, so this will be r minus a. Similarly, the distance between negative charge and point P will be r plus a. So this distance is r, so this is r plus this much is a, so r plus a. Again, this is r minus a, right? Clear? The many students confuse when they are writing the distances. Okay, this is r minus a, this is r plus a. Now what we will do, we will write the electric field because of the positive charge. What is the electric field due to the positive charge? E plus Q. The positive charge electric field is obviously 1 by 4 pi epsilon naught, that is our theta. Okay, like you go to a temple, okay, always you start with the tika. So this is the tika. Whenever you are starting, this is your starting point, right? Next is whatever puja you are going to do, or whatever prayer you are going to offer, right? Now here this is charge 1, q1 plus q. Okay, this is plus 1, so we do not write that. Now what is the distance? Distance is r minus a, sorry, whole square. So this is the force due to the positive charge. Okay, what is the force due to the negative charge? Similarly, we can write 1 by 4 pi epsilon naught. Okay, we are not writing the negative sign here. We will do that by adjusting the directions. Okay, either you can add plus or minus here, or you can do that by adjusting the direction. If you are doing using direction, then you can calculate that direction of the final net electric field directly. Okay, now what I was talking about, what is the direction due to this plus charge? The direction of this plus charge, this is plus, this is also plus, so this will be repulsive in nature, right? So this will be in this direction. Okay, so this is the E plus, okay, plus Q. Okay, now this is minus, so this is plus. So what is the direction of electric field in this case? In this case, the electric field will be attractive in nature, so it will be in this direction. So this is E minus Q. Right? So I hope this clears. Any doubt, any confusion that you may have, if you still have any doubt, any confusion, don't forget to mention that in the comment. Okay, also don't forget to subscribe to our channel, join our WhatsApp channel, and fill up the form if you want the notes of this lecture. Okay, very, very important. If you want the notes of entire question answer series and the derivations, don't forget to fill out the forms. The link is given in the description. Fill the form and you will get the notes directly. Right now, so which force is bigger one? So we have realized that two forces are equal and two forces are opposite direction. They are not equal. Obviously, if they are equal and opposite, definitely electric field would have been zero. They are not equal. One of the force is bigger, one of the force is smaller. Which one is bigger? And how to understand if we don't able to interpret this equation? To understand that, you have to understand this positive charge is closest. So the positive charge is closest means this will have a bigger force. The negative charge is farthest, so this will have a lesser force. Okay, so positive charge will apply higher amount of force, negative charge will apply lesser amount of force. Okay, so the net force in this case will be E positive minus E negative. Why there is a negative sign? Because they are in the opposite direction. That's why this negative sign. Okay, and we are doing positive minus negative because positive force due to positive is more, or electric field due to positive will be more. So now 1 by 4 pi epsilon naught is common. This is there in both cases, so I am writing it only once. Next we will write whatever is this value. So Q by R minus A whole square minus Q by R plus A whole square. Okay, now this Q is also common. So what we will do, we will take Q, this Q also as common. So everything is common, so we will get this value. Now what is this value? How to calculate? So you have to either you can use simple mathematics step by step to calculate it, or you can remember the answer and directly write it. That is also fine. Okay, there is no step mark for this intermediate step. You have to write this, this and this. This up to this step is compulsory. up to this step is compulsory. This step, intermediate step, is optional. Okay, so here r minus a whole square times r plus a whole square. So basically if how to add 1 by x plus 1 by y, suppose. So if you remember that xy, y goes here, y, x goes here, plus x. Mathematics, we are not doing anything new here, it is only simple pure mathematics. Okay, so we just simply multiplied whatever is in the denominator, then this will come here, r plus a whole square, minus sign is here, so minus will be here, and this will go here, r minus a whole square. Okay, now let me write this down, or we can write this as E net equals to q by 4 pi epsilon naught. Let me erase this, I need this space. So what is this term? A plus b whole square minus a minus b whole square. So there is a formula, shortcut formula for this, which is equals to 4ab. 4ab, if you remember it, very good. If you don't remember it, you can break these two squares using a plus b whole square formula, a minus b whole square formula, keep the negative sign in between, apply it properly, find it, you will get the same answer. Or you just remember the formula, it will be easier for you. Now here, if you take the square sign common in the denominator, if you take the square sign common, okay, because both of them are square, so a square b square can be written as ab whole square, right? So if you write it like that, then you see this is a minus b times a plus b, or a plus b times a minus b. What is that? A plus b into a minus b, a square minus b square. So it is r square minus a square whole square. So this is the basic expression here, and what you can do, you can take 2a out of this, 2a out of this, 2aq by 4 pi epsilon naught times 2r divided by r square minus a square whole square. And 2qa is what? 2aq is nothing but the dipole moment. So dipole moment will be p. Okay, this is the general expression. Now there is an approximation. What is the approximation? That this 2a distance, the distance between the dipole, is very small compared to the distance r. Okay, so r is generally very greater than a. Why so? Because the definition of dipole says that the distance between the dipole charges are very small. Okay, so for example HCl, the molecular distance between H and Cl is very small compared to if you are considering dipole moment from it as at a 2 centimeter distance. So 2 centimeter and there will be nano centimeter distance. So nanometer distance is very small compared to 2 centimeters. So that's why this distance, this a distance, we do not consider for this. It will be considered in the top, okay, and it will, you have to apply this thing, okay. The dipole moment is 2qa, okay, that's why we have replaced it. Now for r very greater than a, we can approximate the net electric field to be, this 2 is come here, 2p by 4 pi epsilon naught, r is still there. Now we will ignore this a square. If we ignore this a square, then what is there? R square whole square. R square whole square means r to the power 4, right? Because this a square we have ignored. So you can cancel this and you will get 2p divided by 4 pi epsilon naught r cube. Okay, so 2p divided by 4 pi epsilon naught r cube. This is the final expression for electric field on the axis of the dipole, right? So this is the final answer. I hope it's clear to you. Now we will do the same thing for on the equatorial plane. Okay, this question is more often. This is, suppose this is a 2-star question. Okay, compared to the other question, this question also came once or twice. This is a 1-star question. Okay, so if you have time right now, you have to prepare both of them properly. Okay, and add just before exam, if you are preparing, I will suggest previous one. This one you can skip, but that will be a risk on you. Okay, and if you are preparing right now, you can prepare both the derivations and you can revise both of them before your exam. Okay, now this is the diagram for charges, okay, for equatorial plane. Here we have a positive charge here we have a negative charge. So what is the direction of electric field due to this? So this will be how to find the electric field. Again, you have to remember the steps. First you have to think about, in your mind you have to think about a unit positive charge. Okay, you have kept it at that point of inspection. This is the point of inspection P. Okay, so what is the force? This will be the force. This is positive, so this will be attractive in nature. Now what is the force in this case? This is positive, this is negative, so this will be attractive in nature. This is repulsive, this is attractive. Now if you see this is a 2 vectors, so the resultant vector will be in this direction. This will be the resultant vector, right? Clear? Now how to calculate this thing? First you have to calculate the electric field due to this charge E plus, okay, and then electric field due to E minus. Now because it is in equatorial plane, this distance say r, this distance say r dash, or let me say one more thing, say this distance is x, this is r. Actually this is our distance from the midpoint. We always measure the distance from the midpoint, so this is our distance r. Okay, now this is on the equatorial plane. Equatorial plane means this line cuts into 2 equal halves. Okay, so if this is x, this distance will also be x, right? So both the charges are on the same distance from this point. Both the charges have equal magnitude as well, so the force or electric field basically will be same. The magnitude of electric field E plus and E minus will be equal, because magnitude of the charges are same and they are on the same distance. And what is that value is equals to? That value will be equals to 1 by 4 pi epsilon naught q by x square. Let me say this is equals to E. Everything you have to do, everything you have to write it like that. Okay, and this diagram obviously you have to draw. Diagram requires 1 marks. Okay, so you have to draw this diagram as well. Now the problem in this case is this x is unknown so far. How to find this x? To find this x, we will consider this right angle triangle. We will consider this right angle triangle. What is this distance? This is the half distance. This is A. This is the distance between the point and midpoint, so this is r, and because it's symmetric, this angle is 90 degrees, so this is a perpendicular right angle triangle. Okay, so right angle triangle, we can apply Pythagoras theorem to calculate this, and that x will be square root of r square plus a square. Okay, so now we will put this value here and we will calculate E. So why we are writing only singly instead of writing E plus and E minus? Just to save some time. Both of them have same magnitude, okay, because the charges are of same value, distance is same. So instead of writing E plus, E minus, E plus, E minus, we just using a single variable E, okay, which is sufficient for us. So 1 by 4 pi epsilon naught, Q is Q, magnitude only one charge, and this is x square, so x square means r square plus a square. Okay, r square plus a square, square root, whole square cancels. So simply r square plus a square, right? Now this is E. Now the trick begins. So what is the trick? The trick is there is a geometrical symmetry. Okay, so this line and this line are parallel. So this is a bisector. So this angle and this angle should be same. Okay, similar angles. Now here this angle and this angle will be same. This is an alternate angle. Okay, so Z, I said always there is a Z or reverse Z. This will always be same angle, right? So this is also same angles. Now interestingly, this angle and this angle are also same, right? This is a as I said, this is a equatorial plane. So this line divides into two equal halves. So whatever this distance, same distance is here. So this is an isosceles triangle. Okay, isosceles triangle means these two sides are equal. These two sides are equal means these two angles will also be equal. Okay, so this is the trick. So if this is theta, this will also be theta. Okay, so what we have to do, we have to take two components of this E plus. What is this? One component is along this direction, one component is along this direction. Similarly, for this also we will take two components. One component is along this direction, another component is along this direction. Now as you can see, these two components will be equal and opposite, they will cancel each other. So only component that we need to consider is this component. Okay, one will come from E plus, one will come from E minus. Now both of the components are in the same direction. So in this case they will be added. Unlike previous case where they were subtracted, in this case both will be added. Okay, so and what is this component? This is E cos theta. What is this component? This is also E cos theta. Both are adjacent to theta. That means this will be E cos theta, this will also be E cos theta. So basically this is nothing but 2E cos theta. Okay, so 2E cos theta is the net electric field. So you have to draw, you have to show everything in this diagram. Okay, you have to show this theta, this theta, this theta, this theta. Okay, I am doing it step by step. If you want, you can do it step by step. If you don't want, you can draw everything. Okay, because if you have understand that concept, you can do it as I am doing. Okay, if you just memorize everything and try to vomit in your answer sheet. Okay, I have remembered everything, I just vomit it, go there and vomit it, then you have to draw it once. Okay, jokes apart, I know many of you try to understand, some of you have not doing it well because you have not interested in physics for a long time. Now everything looks like different language. Okay, for example, I say my students, it looks like Hebrew to them. Okay, Hebrew is a language, very difficult language. So it is not Hebrew, this is English, this is Kannada, this is your physics. Okay, not difficult to understand. If you have spent some time in your past 2-3 years, which you have not, okay, everyone was busy solving biology, some of them are solving mathematics, but physics everyone ignored, thinking it is too easy, too simple, but actually it is not. Okay, now let's do the net electric field. Net electric field, as we said, it is 2E cos theta. Okay, for example, this method of dividing into two components, this method we have learned in your PU1. Now if you have not spent too much time in your PU1, you have wasted your time, you wasted your life. Now I cannot help you, I cannot teach you why these components are cos theta component. Okay, for now you can have to remember that adjacent components are cos theta. Okay, now so 2E cos theta, what is E? E value you already know. So 2 times 1 by 4 pi epsilon naught, okay, Q by R square plus A square cos theta. Now what is cos theta? That is also important. Okay, we cannot leave it using a cos theta like dot product, cross product. No, here we have to find the angle theta as well, because this theta is nothing to do with electric field and dipole moment. Okay, we have to find this theta as well. What is this theta? Cos theta, right? Cos theta means some people have curly brown hair, base by hypotenuse. So what is cos theta in this case? In this triangle, okay, base, if this is angle theta, this is base, base is A. hypotenuse is x, that is square root of r square plus a square. So this is cos theta. So you have to just put this value here, a by square root of r square plus a square. Okay, now let me rewrite this. 2qa divided by 4 pi epsilon naught, okay, 1 by r square plus a square times r square plus a square whole root, that is r square plus a square to the power 3 by 2. Okay, this is simple mathematics. Now what is this 2qa? 2qa is nothing but p, 4 pi epsilon naught. Okay, and what is 1 by r square plus a square to the power 3 by 2, as we have to do the simplification that r is very greater than a, so we will ignore this a square in the denominator. We will write this as r square to the power 3 by 2, there is 1, or we can write this as p by 4 pi epsilon naught r cube. Right, so this is the expression for innate. Now in this case the dipole moment is from negative to positive. Okay, dipole moment is from negative to positive, that is the direction of dipole moment, and the electric field is in this direction. So vectorially, if you are writing this in vectorially, okay, then it will be E net equals to minus p vector divided by 4 pi epsilon naught r cube. Okay, now if you compare this with our previous expression, okay, in our previous expression you can write net electric field like E net equals to 2p vector divided by 4 pi epsilon naught r cube. First of all, there is a 2 extra. Secondly, they are in the same direction. In this case, electric field, net electric field was in this direction. Net electric field was in this direction, right? Because EP was positive, so E plus 1 is positive. So this was the direction of electric field. Okay, this is the direction of net electric field, and a dipole moment is also from negative to positive. So this is the direction of dipole moment. So this was plus. So in this case the angle between dipole moment and electric field is 0. I asked you during my MCQ section that answer this question if you know it in the comment below, and if you are answering right now, I will not accept that answer. Okay, but if you understand that the angle between dipole moment and electric field is basically 0, okay, in case of axial position. Now let's move into the next question. Derive an expression for the electric field at a point due to an infinitely long, thin, uniformly charged straight wire using Gauss's law. Now in this case, sometimes they will ask you state Gauss's law and then find expression for uniformly thin wire. Okay, so in that case you have to do the statement. I am not giving you here. I have already given you in a short answer type section. So from there you have to write the statement. Okay, so here we have a straight wire carrying current. I am just saving some time from my side. I don't want to draw. My hand is paining, right? So that's why I have taken some shortcut. I have taken this picture from your book, and you have to draw this diagram while writing the answer in your exam. You have to draw this diagram. Okay, maybe not exactly as it is, but similar to this. Okay, so here we are trying to find electric field at a distance r from the charged wire. This is a charged wire, not a current carrying wire. Current carrying wire is a magnetic field, that is a different derivation. I have seen student this question was asked and they have done current carrying wire formula, or sometimes current carrying formula was asked, they have derived this one. Okay, so you have to basically understand this is Gauss's law and this is because of charged wire. Okay, not current carrying wire. Current carrying wire is different, that is the law is different, either Ampere's law or Biot-Savart's law. Here we are using Gauss's law. Okay, now so we are trying to find electric field at a distance r from this wire. So how to do that? First we have to consider a cylindrical section, cylindrical Gaussian surface. Okay, cylindrical Gaussian surface. So this is a cylindrical Gaussian surface, okay, of length L and radius r. This is our first consideration. So we have considering a cylindrical Gaussian surface of radius r and length L. Okay, now so if we consider this, then from Gauss's law we know that integral E dot ds equals to Q enclosed by epsilon naught. This is the statement, okay, from Gauss's law. Now what is the charge enclosed here? For that you have to declare one variable. This variable you have to declare. Let the line charge density of the wire is lambda. So we have defined this quantity, the line charge density. Okay, this one you have to definitely define. Okay, now if this charge is line charge density, means if you consider a unit length, the charge in that unit length is lambda. So for 1 meter length the charge is lambda. What is the charge for L meter length? So charge for 1 meter is lambda, for L meter length. So in this case you can say therefore Qn is the charge enclosed within this line charge element, right, within this section. So within this section means L times 1, right? So L times lambda. This is the charge enclosed, right? This is the charge enclosed by this cylinder. Now if you see, electric field will only be in this direction or in this direction, okay, either in this direction or in this direction. There will be no electric field going in this direction. That will create paradox, okay, because there is a line itself is there. So line cannot be in the same direction, electric field cannot be on the same direction on the line, right? So electric field will only be in this direction. So we will not consider these two surfaces, we only consider the curved surface. So when we are considering the electric field, we will only consider the curved surface. Also, all the points on this curved surface are equidistant. All the points are equidistant on this line. So that means this electric field, the magnitude of the electric field will be constant on this curved surface. These things you have to remember it. You don't need to write it, but you have to remember it. So what we can do, therefore, this due to symmetry, due to E is constant on the surface of the cylinder, therefore E is constant, E ds equals to Q enclosed is L lambda divided by epsilon naught. Now what is this ds is? That is the main thing. So ds is basically the surface area. Total integration ds is representing the surface area. Here the surface area of the curved surface. What is the surface area of the curved surface in case of a cylinder? So if you have to remember that, in your class 10th you have done that, 2 pi RL, right? 2 pi RL is the surface area of the curved surface. So it is L lambda by epsilon naught. Okay, or if you do the math, E will be equals to 1 by 2 pi RL times L lambda divided by epsilon naught. L cancels, because here we assume the length L. We are finding it for infinite length of wire, but while drawing this diagram we assume the Gaussian surface. Here you have to mention the Gaussian surface. Okay, Gaussian okay, and this diagram is also in this case mandatory. You cannot skip that. So it will be 1 by 2 pi epsilon naught lambda by r. So electric field in this case, as you see, is inversely proportional to the distance. It is not square of the distance. This is very, very important. So in case of dipole, electric field depends on inversely proportional to the cube of the distance. In case of line charge, this is inversely proportional to the distance, not square of the distance. So these are very, very important points to remember. Now next question: state Gauss's law in electrostatics. Derive an expression for the electric field at outside the uniformly charged shell. This is very simple, very easy, asked only few times. Okay, previous one was very common. This is very simple derivation. So we have a shell, charged shell. Shell means, what is the meaning of shell? Shell means the husk. For example, if you are if you eat egg, or if you have seen egg, okay, when they broke the egg, when the egg is out, the white cover which covers the egg is called shell, egg shell, right? Shell means the cover, inside is hollow. Okay, or if you are playing tennis ball, okay, once the tennis ball is broken, the outer covering is the shell, inside it is hollow. Okay, so similarly we have a metal shell, conducting shell, okay, and we are trying to find electric field outside. Electric field inside will be 0, okay, because all the charges will stay on the shell itself. No charges will stay inside. So if you consider any Gaussian surface here, electric field inside will be 0. Just for your information, electric field outside, we are trying to find electric field on the outside. How to do that? Suppose the total charge on the shell is Q. Total charge on the shell is Q, and we are trying to find at some distance R. Okay, and the radius of the shell is capital R, even though not required. Okay, very simple. Here we will consider a Gaussian surface. Okay, you can consider a Gaussian, spherical Gaussian surface, okay, at a distance R. Then using Gauss's law, we can write E dot ds equals to Q by epsilon naught. Obviously this is Gauss's law. Now again, this is a sphere, so sphere also have a symmetry. Sphere, circle, then cylinders, they are all symmetrical. Okay, they have different angles of symmetry. Sphere is the most symmetrical object because it has symmetry in all the possible direction. So because of the symmetry, electric field will be constant. You have to write due to symmetry dot dot dot, the same line that I have written in the previous problem, same line you have to write it here. Okay, and E dot ds, so you can take E out because it is constant. So ds equals to Q by epsilon naught. Okay, so this distance is R, this is a sphere. So what is ds? Surface of a sphere. Surface of a sphere is 4 pi r square, right? 4/3 pi r cube is the volume, 4 pi r square is the surface area. So Q by epsilon naught. So electric field E is basically 1 by 4 pi r square Q by epsilon naught. Rearranging, we get E is equal to 1 by 4 pi epsilon naught Q by r square. So basically, as you see, this is same as a point charge. This is same as a point charge located at the center of the sphere. Okay, but you cannot write it directly. You have to do these steps because they asked you from the Gauss's law, and statement of the Gauss's law obviously done in our short answer type questions. Okay, now So we have completed all the derivations, all the important derivations. Now let us look into some numerical questions. 2 point charges plus 4 nanocoulomb and plus 8 nanocoulomb are placed at the points A and B respectively, separated by a distance 0.2 meter in air. Find the magnitude of the resultant electric field at the midpoint O of the line joining A and B. What will be the magnitude of the resultant electric field at O if plus 4 nanocoulomb is replaced by another plus 8 nanocoulomb charge? So you can pause the video, try to solve this numerical, okay, then you can check the answer once I solve this. Okay, this is a request, and tell me how many of you are going through till this point. Okay sir, I have reached the numerical section. Okay, and if you want to skip the numerical portion, obviously you can, but for all the students I recommend to go through the numerical questions. These are little bit this will give you some clarity, some concept development happens when you solve numericals. If you just want to pass the exam, you can skip this part. Okay, for anyone who is willing to score well in your PU board, definitely you have to solve this. Okay, now let's see. So we have 2 point charges plus 4, okay, nanocoulomb and plus 8 nanocoulomb, okay, and placed at points A and B. So this is at A, this is B, okay, separated by a distance 2 meters in air. So the distance between them is 2 meters. Okay. Now find the magnitude of the resultant of the electric field at midpoint O. Midpoint O, we are trying to find the magnitude of the electric field. Okay. What will be the magnitude of the resultant? Okay. First, let us understand the direction of electric field always. So what is the electric field due to this positive charge? This is positive, so if you keep a unit positive charge, it will be repelled. So this is the E plus 4. And what is the direction of this charge? This will be in this direction. This is E plus 8. Okay, so the plus 4 will be in this direction, plus 8 will be in this direction. So both forces will be opposite direction. Now who is bigger in this case? The bigger one is obviously this one, because this has a higher charge. Both the point is equidistant because it is in the midpoint. Midpoint means whatever distance this is, the same distance will be this. Now what is that distance? That distance is 0.2 divided by 2, that is 0.1. 0.1. Okay, I hope this is clear. Okay, 0.1 meter in this direction, 0.1 meter in that direction. Okay, so both of them are equal. Now okay, now what is E plus 4? E plus 4 is KQ by R square. Now while solving numerical, I don't write 1 by 4 pi epsilon naught, I write K. Why? Because K value is known, 9 times 10 to the power of 9, right? We know this value. So if you write 1 by 4 pi epsilon naught, then again you have to write one extra line, 1 by 4 pi epsilon naught equals to 9 times 10 to the power 9. So that creates confusion. If you write it directly like that, it does not create any confusion. You know this is a Coulomb constant and its value is K times 10 to the power of 9. Now what is Q? Q is, we are doing it for plus 4, right? So 4 nanocoulomb. Nanocoulomb means what? Nanocoulomb means 10 to the power of minus 9 divided by R square. R square is 0.1 whole square. Okay, so 4 9s are 36. This 10 to the power of 9, 10 to the power of minus 9 cancels. 36 divided by 0.1 whole square. What is 0.1? 0.1 can be written as 10 to the power minus 1. Right? So 10 to the power of minus 1, if you do the whole square, then it will be 10 to the power of minus 2. So you can say this is 10 to the power of minus 2. Or this will be 36 times 10 to the power of 2, or this will be 3600. Okay, so this will be 3600 Newton per Coulomb. Okay, unit is very important in this case. This is a numerical question and unit is very important, and this is not an MCQ question, not a case set question, so you cannot skip the units. Okay, if you don't write the units, they will definitely deduct 1 mark, and this problem requires a diagram, so drawing the diagram give you 1 mark. Okay, diagram is not absolutely necessary, but this is important and it is required, so they will give you 1 mark to draw this diagram. Calculate E plus 4 1 mark, calculate E plus 8 1 mark, calculate the net field 1 mark, and the last part 1 mark. So 4 marks are there. Okay, and that's it. 1 mark is for the diagram, 1 mark is for the plus 4, 1 mark is for plus 8, 3 marks, and then resultant electric field is 1 mark, 4 mark, and last part there is a last question, what will happen, that is 1 more mark. So total 5 marks you will get. So you have to understand that if you falter in these two, calculating these parts, you will not be your answer will not be evaluated for the next part. So obviously you have to calculate these two parts carefully, then only your answer for the next part will be calculated. And you have to practice these questions. Even if I am giving you the solve question, check this question if you are able to solve this correctly or not. I have seen students doing lot of mistakes in the units. Unit conversion, value calculation, simple derivation, division, they are not able to do. So for example, I have done 10 to the power of minus 2, then I have taken this 2 and 3600. I know many students will do it 0.36. I know many students will do this calculation as 0.36. If you are one of them, then you have to practice mathematical part of this equation, these calculations. Okay, again and again and again and again till your brain is tuned. Your brain is mistuned because you have wasted 2 years of your life during pandemic, and that has created a lot of confusion, lot of basic mathematics you still are not able to grasp. Okay, so K is 9 times 10 to the power of 9. Now I know many teachers who teach in the class, they are still thinking you are the best students. They don't focus properly on the weaker sections, they only focus on the good students. And good students, okay, they are passing, but the weaker students, they are falling behind because they wasted too much time during their pandemic. Okay, they had work from home time and they have not studied anything, and they have ignored mathematics, physics classes, so now they are struggling. That is the basic reason. Okay, so if you are one of them who wasted a lot of time during pandemic, then this is the time to make up. Okay, you have no other option. Okay, now 10 to the power of 9 minus 9 cancels, 8 9s are 72 divided by 10 to the power minus 2, or 7200. Okay, so this is the electric field, positive charge. Now positive is in this direction, negative is in this direction, so they are equal and opposite. Sorry, my mistake, both of them are positive. Plus 8 is in this direction, plus 4 is in this direction, and we see that plus 8 is bigger than plus 4, so the net electric field will be E plus 8 minus E plus 4. Why like that? Because plus 8 is bigger, and trust me, this is a very simple problem from one of your model question paper. So plus 8 is positive, 7200 minus 3600, so it will be 3600 Newton per Coulomb. Okay, so 72 minus 36 is 36, so 3600 Newton per Coulomb. This is the answer for the first part. Now what is the second part, last part? Okay, what will be the magnitude of the resultant electric field at O if plus 4 nanocoulomb is replaced by another plus 8 nanocoulomb? Very interesting question. So in this case, what is happening? You are replacing this charge using another plus 8 nanocoulomb. So here already one plus 8 was there. Here another plus 8 you are keeping. You are removing the plus 4 and you are asking what will be the electric field at this point. Okay. So this is very interesting and understandable, understanding based question, that this will be repelled. Okay. This plus 8 will repel in this direction, this plus 8 will repel in this direction. Now both the charges will have same magnitude. So in that case, electric field due to both the charges will be same but opposite direction, so the net electric field will be 0. So we have to write that here two charges will be equal, thus the net electric field will be 0. Okay, that's it. Or you can do the mathematics like that and you can calculate 7200 minus 7200 is equal to 0. That is also fine. This is a shortcut way to write. So the answer is 3600 and 0. Okay, so this is the answer. I hope we have calculated correctly. Now let's move on to the next question. 2-point charges QA equals to 5 microcoulomb and QB equals to minus 5 microcoulomb are located at A and B separated by 0.2 meter in vacuum. So similar question, instead of air, here they are giving you two charges A and B, and this question is based, similar question like this came in 2024 exam. Okay, 2024 exam, only the values are different. I think 18 microcoulomb and 15 microcoulomb and 10 microcoulomb, minus 10 microcoulomb. That was the values. Okay, here it is slightly easier. 5 microcoulomb and minus 5 microcoulomb. Okay, are located at A and B separated by 2 meters. Same and similar question. Okay, and if they give you in centimeter, for example, if they ask you 20 centimeter, this question came in 2024 with 20 centimeter distance. 20 centimeter is same as 0.2 meters. Okay, and if you have any difficulty understanding that how to convert it into centimeter to meter, during my KSET class I explained that instead of dividing by 100, what you can do if the distance was given say 20 centimeter. So what you have to do, you have to multiply by 10 to the power of minus 2 to get it in meters. Okay, simple. If you do it, it will save a lot of confusion due to negative sign. Okay, you can simply do the square and you can transfer the 10 to the power term in the numerator by making it positive. That's it. Very easy. Okay, if you solve it like that, then it will be very, very easy for you. Maybe when I do previous year question paper, I will explain it. Okay, now but if the exact question there is a very rare chance that exact question will repeat in your year, but they will change the data, they will change the language. That's why I have give you a new question. Okay, now what is the electric field at the midpoint O of the line joining the two charges? So what is the midpoint O, what is the electric field? Now in this case, this is positive, so this, if you keep a unit positive charge here, you will observe that positive charge will be repelling it and the negative charge will be attracting it. So both electric field due to positive and due to negative, both will be from O to B. Okay, it will be from O to B and they will be adding up. So if you find electric field due to any one of the charge, you can simply just double that to get the electric field. Okay, so what I am talking about, so plus 5, electric field due to plus 5, KQ by R square. What is r square? Total distance 0.2, so this will be 0.1, this will be 0.1. So kq, similar thing, okay, similar thing. 9 times 10 to the power of 9. Only thing here they have given you microcoulomb. Microcoulomb means 5 times 10 to the power of -6. Micro means -6, nano means -9. Okay, and r square is 0.1 whole square. So we already know that 45 times 10 to the power of 9 minus 6 plus 3 divided by 10 to the power of -2. Why into the -2? I explained in our previous problem. So 45 times this will go up, and if it goes up, minus becomes plus, so 10 to the power of 5. This is the electric field due to positive charge. Similarly, the electric field due to negative charge will also be 45 times 10 to the power of 5 Newton per Coulomb, because both of them are same charge. Previous case, one was +8, one was +4. That's why we had to calculate twice. In this case, both of them are 5 only. Charges sign are different, so electric field direction will be different, but magnitude will be same. Right? Now from the diagram we can see that both are in the same direction, so the net electric field in this case will be E plus 5 plus E minus 5, that is equals to 45 times 10 to the power of 5 plus 45 times 10 to the power of 5, that is 90 times 10 to the power of 5, okay, Newton per Coulomb. This is the force. Now what is this part is over, the force part is over, electric field part is over. Next is the force part. If a negative test charge of magnitude 2 nanocoulomb is placed at O, what is the force experienced by the test charge? So what is the force experienced by the test? Now what is the direction of this? This direction is OB. The direction is along OB. Okay, as you can see, the direction is along OB. Now part 2, okay, or part B basically, this is part A. Okay, so in this case, what is the force? We know that force is Q times E. Force is Q times E. Q is given by 2 nanocoulomb, and this is 90 times 10 to the power of 5, okay, Newton, or if you do 180, 90 times 2 is 180, 10 to the power of -9, 10 to the power of 5, so it will be 10 to the power of -4, or you can write this as 18 into 10 to the power of -3 Newton, or 18 millinewton. Whatever, it is fine. 18 times 10 to the power of -3 Newton, or you can write this as 0.018 Newton. Okay, whatever you are comfortable with. Let's see the answer. Here the answer is given 9 times 10 to the power of 6. I have written 90 times 10 to the power of 5. Correct, both are correct. Okay, you can take this 0 here, you can take the 0 to the power. Okay, and 18 times 10 to the power of -3, correct. Okay, so both answers are correct. Now let's go to the next problem. 3 charges each equal to +4 nanocoulomb are placed at the 3 corners of a square of side 2 centimeter. Find the electric field at the 4th corner. Very interesting question. Here we have 4 charges, sorry, a corner square, a square of side 2 centimeter, okay, a square of side 2 centimeter, okay, and we have charges, both sides are, all the sides are 2 centimeter, not both, all 4 sides are 2 centimeter. Okay, and you have keep, suppose you have a charge here, you have a charge here, you have a charge here. Okay, now we are trying to find the electric field at this corner. So A, B, C and D. We are trying to find electric field at D. How to do that? So this is plus Q, this is also plus Q, this is also plus Q, and that is equals to plus 4 Newton nanocoulomb. Okay, so if we keep a unit positive charge here, what will be the direction of this? This will act in this direction, this will act in this direction, and this will act in this direction. Okay, okay, sorry, my mistake, give me a moment. Okay, so you have to calculate this net electric field of these three electric fields. Okay, how to do that? First of all, we will calculate the electric field due to these two charges. Okay, E plus, E plus, both of them are same distance, 2 centimeters, both of them has same magnitude. So electric field EA should be equals to electric field EC. Okay, and what will be that value? That value will be KQ by R square. Right now I am keeping it in normal general values. Last moment I will put the values. Okay, so don't worry. Now these two electric fields are perpendicular to each other. So what will be the sum of these two electric fields? That is, if we add, we will add one by one. So this is EA, EC, this is EA. If we add these two fields, so this is EC, this is EA, if we add, they will be along this direction. It will be along this direction. So what is that magnitude is? Two perpendicular vectors. Okay, if we want to find the magnitude, so this is E dash, intermediate. That's why I am saying E dash. E dash will be square root of EA square plus EC square. Now EA and EC both are equal, so both are equal, and say that value is E. So what we will do, E square plus E square or equals to E root 2. Okay, so E root 2 is the magnitude of this electric field, these two electric field. Now what is this electric field? That is very interesting. So if we calculate this electric field and add with E dash, we will get the final electric field, right? Both of every electric field will be in the same direction. Now what is this electric field? This is this is 2 centimeter. We are saying R in this case. This is R, this is R, this will also be R, then this will be R root 2, right? This is the corner of a square. Corner of a square is, or diagonal of a square is R root 2. So the electric field EB will be equals to KQ by R root 2 whole square. So it will be half KQ by R square. Now what is KQ by R square? KQ by R square is equals to E. So it will be half of E. So what is the net electric field? The net electric field is E root 2 plus half E, or it will be half plus root 2 E, or it will be half plus root 2. What is the value of E? Let me now calculate the value of E in one of the corner. Okay. What is E? E is 9 times 10 to the power of 9. KQ, Q is 4 nanocoulomb, so 4 times 10 to the power of minus 9, and the distance is 2 centimeter. 2 centimeter is 2 times 10 to the power of minus 2 whole square. As I said, it will be 2 times 10 to the minus 2. When convert, this will be easier for you to write. So now this 9 cancels. So 9 times 9 times 4 divided by 2 square. 2 square is 4 times 10 to the power of minus 2 square. 10 to the power of minus 2 whole square is 10 to the power of minus 4. Right? So 4 cancels. This minus 4 will go up and become positive. So 9 times 10 to the power of 4. Okay, so this is times 9 times 10 to the power of 4. You can simplify this, you can leave it here, but don't forget to write the unit Newton per coulomb. If you simplify this, you will get 17 times 10 to the power of 4, or you can just leave it here. Both are fine. Okay, both are fine. This will also give you full marks, this will also give you full marks. Okay, if you have the access to calculator, obviously in your board exam you have access to the calculator, you can use you can calculate it, you can find the exact value. Okay, otherwise this is also very fine. Next question, a conducting sphere of radius 10 centimeter has an unknown charge. Okay, if the electric field 20 centimeter from the center of the sphere is 1.5 times 10 to the power of 3 Newton per coulomb and points radially inward, what is the net charge on the sphere? So here we have a charge, only the magnitude is important, so direction of inward or outward does not matter. Inward, you should remember, this should be a negative charge. If it is outward, that is a positive charge. That's it. But here only the magnitude is sufficient. We have a charge Q, okay, in a spherical shell. Now as we have learned that when you are finding the electric field outside, okay, electric field outside, the electric field is given by simple like a point charge, kq by r square, and you can consider the entire charge is located at the center of the sphere, right? So this is the center of the sphere, the charge is r. Now you can say what is the electric field? Electric field is 1.5 times 10 to the power of 3. What is k? K is 9 times 10 to the power of 9. This is a simple one line question. Okay, distance is 20 centimeter. Q we are trying to find. Don't confuse with the Gauss's law. This is also, obviously you can do Gauss's law here, but from the Gauss's law the formula is already derived. For a spherical shell, as long as you are calculating outside, you can consider the entire charge is located at the center and you can simply apply this point charge formula. Okay, so from here you can calculate Q. Okay, so Q will be 1.5 times 10 to the power of 3 times, so cross product, okay, this will go up, this will come down. Okay, so cross product 20 times 10 to the power of minus 2 whole square divided by 9 times 10 to the power of 9. Okay, this will cancel. 1.5, 9 is 6. Then let's do the square. 20 square is 400 times 10 to the power, there is a 10 to the power of 3 here. Here is 10 to the power of minus 4, minus 2 whole square, so minus 4. This 10 to the power of 9 will go up, it will become minus 9, and everything is divided by this term 6. Okay, so you can say that 400 divided by 6, or let me take out these two zeros. I will adjust it in the 10 to the power. So 10 to the power of 3 minus 4 minus 9, I have taken these two zeros as well, so it will be plus 2. Okay, 5, 13 minus 5 means 8, so minus 8. So into 10 to the power of minus 8, or 2 by 3, so it will be 2/3 times 10 to the power of minus 8, or 2/3 is basically 0.67 times 10 to the power of minus 8. Okay, so if you see the answer, it will be 6.67 times 10 to the power of 6.67 nanocoulomb. So you can write this as 6.67, because this is repeating, so you can write this as well, 10 to the power of minus 9. Okay, so you have to, what you have done, you have taken 1 multiplied by 10 here and make it 10 to the power of minus 9. So that is also fine. So but the unit is coulomb in this case. Okay, and if you take this 10 to the power of minus 9, then it will become 6.67 nanocoulomb. Okay, this is the answer. Anyway, any one of this answer is correct. This is correct, this is correct, this is also correct. Any one of the answer if you keep, you will get full marks. Okay, as long as your calculation is correct. It is simple question, but I know many of you will not be able to solve this question. Next, the last question, I think. A polythene piece rubbed with wool is found to have a negative charge of 3 times 10 to the power of minus 7 coulomb. Okay, estimate the number of electrons transferred from which to which. First of all, from which to which? Is there a transfer of mass from wool to polythene? Okay, so first of all you have to check that. Polythene piece is rubbed with wool is now found to have a negative charge. So polythene piece is now negative charge. So polythene piece is negative charge means wool has transferred electron from wool to polythene. Okay, so electrons transferred from wool to polythene. Okay, because as we know electrons are negatively charged, so wool has given away its electron to polythene, that's why polythene is now negatively charged. Now how much negative charge it has given? So say n number of electrons are being given to polythene. So if n number of electrons are given, then we know that charges are quantized in nature. N times E should be 3 times 10 to the power of minus 7, right? Q is any quantization of charge. Q is any charge can be written as n times E. Okay, n is the number of electrons transferred. Okay, E is the charge of one electron, or n times 1.6 times 10 to the power of minus 19 is equal to 3 times 10 to the power of minus 7. Okay, or n equals to 3 divided by 1.6 times 10 to the power of minus 7 divided by 10 to the power of minus 19, sorry, or it will be almost 30 by 16. You can use your calculator. I don't prefer to use calculator anytime, so that's why I am solving it like this. Okay, 8, 15. Okay, so it will almost 2, but not exactly 2. It will be about 1.9, I think. 1.9 times 10 to the power of 12. This is the number of electrons transferred from wool to polythene. Okay, this is the part. Now, is there a transfer of mass from wool to polythene? Now, electrons have very low mass. Okay, you can calculate that exact mass. It is very small. So you can the transfer of mass from wool to polythene is negligible. So you can say first of all you have to write the transfer of mass is negligible as the mass of electron is very small. Okay, so this is the answer. I hope you enjoyed today's lecture. Okay, this answer is not updated, I think. Okay, this is from the previous question. But I hope you enjoyed today's lecture, and if you want to know about the important topic of this chapter, this is a very important part of the entire lecture. Okay, here if you go through this table, it will be helpful for you to revise the chapter quickly. So what all the conceptual questions might come from this chapter? Coulomb's law, very important. Properties of charge, very important. Properties of electric field lines, also very important. Electric dipole, definition of electric dipole moment, etc. Gauss's law statement, explanation, important. Next, what are all the formulas that you have to remember? Now formula, this is only formula. This formula, you also have to remember the formulas you are learning in the derivation section. This is specific, which you don't need to learn the derivation, but you have to remember the formulas. What are all those? Electric field due to a point charge, kq by r square. Okay, free force on a point charge, is q times E. Right, electric field due to a point charge, electric field due to a charged plate, sometimes that comes handy. Sigma by epsilon naught, that is also sometimes important, sigma by 2 epsilon naught. Okay, electric field due to a dipole, two positions, all the positions important for derivation, also the formulas are important. Okay, electric field due to, so this is basically only formula here, derivation plus formula. Okay, formula is by default is common. Okay, if you are doing the derivation, you have to remember the formula, right? Electric field due to a long straight wire, electric field due to a spherical shell. These are the most important concept from this chapter. You have to remember this concept for your PU exam. Okay, and the formulas for your KCET exam if you are preparing, or JEE mains exam or NEET exam. Okay, so I hope this lecture was very engaging for you, and if you want to download all the lectures, you have to fill the form given in the description below, and don't forget to subscribe to our channel, like this video, share with your friends. I will be back with a new video in our Friday's class. Till then, bye.